Shouldn't teachers be paid more if their students learn more? Well, here's a teacher and her students, and here's another teacher and her students. Suppose we give both classes a reading test at the end of the year, and we find that these kids average 77% and these kids average 82%. Should this teacher be paid more? Well, that's obviously not fair, because it could be that these kids didn't start with the same skills when they entered the class. So one idea is that you give a test in the fall and give a comparable test in the spring and examine how much the kids have gained over the year. Now we might find that when we look at these different scores, this teacher has actually done a better job. This is called a value-added measure, and lots of people think it's a good way to evaluate teachers. Well, is it fair?
The answer is no, and I'll give you 6 reasons why in the next 3 minutes. Problem 1, missing data. Here are the scores for the fall, and here are the scores for the spring. Oops, those kids moved away during the year. Can we just ignore those scores? No, because kids who move away more often tend to be the poor kids, not the rich kids, and poor kids tend to score lower on these tests. So if we just ignore these scores, we could be biasing our evaluation of the teacher. Problem 2, reduced reliability. As you would expect, the kids who scored the best in the fall are likely to score the best again in the spring, and likewise for the kids who score in the middle or the lowest. Everybody improves some, so the ordering of the scores doesn't change a lot. In other words, the scores from the fall and spring tend to be correlated. I know, that's obvious. Here's what's not obvious. When scores are correlated, any different scores you calculate from them will be unreliable. Reliability refers to whether a measuring device, like a test, is consistent. An unreliable bathroom scale would be one that gave you a different weight every time you stepped on it. What? The reasons for this are technical, but here's the scary formula that describes it. So taking the difference between fall and spring test scores sounds reasonable, but it means that these scores tend to be unreliable, like the scale that can't make up its mind. Problem 3. The same score gains might not be equivalent. The teacher who moves her kids from 75 to 80 on a test is supposed to be as good as the teacher who moves her kids from 85 to 90. These intervals look the same on the test, but who says they're equal for the teachers? Smarter kids might be easier to teach, or maybe if you start near the bottom of the test, it's easier to move up. Probably depends on the test. Problem 4. Other people affect what teachers do. My principal is supportive and helpful. My principal isn't. Well, I guess I'm going to make more money than you. Problem 5. Should teachers only worry about short-term gains? What if some things won't be tested at the end of the year, but will be important in future years? Things like broad knowledge of the world, which is vital for reading comprehension. Why encourage teaching only what's important in the short term? Problem 6. Effects of peers. 2 classes might start the year with the same test scores, but one might have mostly well-behaved children, whereas in the other class the children are a little rowdy. Okay, who wants the rowdy class? Anyone? Merit pay can't work until there's a way to measure teacher performance that's fair. That's right.